Number 2 was to add the two fractions together, 1/5 plus 2/3. This is not the kind of thing we would see that much of. In fact, in this class, we'd probably just turn them both into decimals and just add the decimals up. But some of these kind of lead to some other ideas which are important, so that's why I put them in there. 1/5 plus 2/3, there's no simple way to combine those kind of as is. The problem is that it's sort of an apples and oranges. Fifths and thirds just don't line up very well. 1/5 again is, think of a pie and 1 pie and divide it 5 ways. So, there's a fifth of a pie. 2/3, you could think of that as 2 pies divided 3 ways. Or you could have 2 portions of 1 pie divided 3 ways. In other words, take a pie and divide it into thirds, and then take 2 of those portions. So there's a fifth, there's 2/3. Altogether, that's coming close to a whole pie. Not quite, maybe a little bit less, but close to a whole pie. But they're thirds and fifths. They don't line up very well, so they're hard to combine. The trick to doing this is to put these in a different form, to change them to a different kind of fraction that can be combined. For instance, if they were both expressed as 15ths, in other words, split both of these into 15ths. So now you have some 15ths here, and it's hard to see, but that's in 15ths as well. Those are all the same size slice, so when you had that, you could just add the tops together and you'd be done. So now the question is, how do we turn this into 15ths? The trick for that, the rule is, you can multiply top and bottom of this fraction by the same number. I got 15 from 3 times 5 in the first place. There may be, that's what they call getting a common denominator. There may be smaller ones than just multiplying these together sometimes, but that's not really important for us. This times this will certainly work. So to get fifths into 15ths, we can multiply top and bottom here by 3 over 3. So that gives us 3 times 1, 3 15ths down there. To make this look like 15ths, multiply top and bottom by 5 will work. So 2 times 5, 10. We have 5 15. So this is actually 3 15ths. This is 10 15ths. Together gives you 13 15ths. So that was the correct answer for that one. Again, close to a whole pie, but not quite. A little bit less. This right here is actually a fairly important idea in math. We multiplied by 3 over 3. But 3 over 3 is also a fraction. 3 over 3 is just 1. If you took 1 pie and divided, or took 3 pies and divided by 3 people, you get 1 whole pie per person. So multiplying by 3 over 3 is just the same as multiplying by 1. In math, there's a real short list of very special operations that you can always insert pretty much anywhere because they have no effect. And they'll make a big deal out of them, and they seem so simple you wonder why, but they really are important. Times 1 is one of them. You can always multiply things by 1. You can always insert a times 1 in pretty much any mathematical expression because it doesn't change anything. Think in terms of your checkbook, for instance. You can put a times 1 anywhere in your checkbook. Multiply your paycheck times 1 or your Visa bill by 1 or whatever, and there's no problems. But that's pretty special. It doesn't work for anything else for multiplying. Times 2, times 7. If you start multiplying things by 2 in your checkbook, multiply your paycheck by 2 or divide your bills by 7. Right away you and the bank are going to have a disagreement or problems. The times 1 is pretty special. That's what they call an identity operation. Another one in math is adding 0. It's always legal to add 0 anywhere you want to in a mathematical expression. It has no effect. We won't do that so much, but we actually will do a lot of that. But what happens is, instead of just multiplying by plain old 1, lots of times you'll do something equivalent. You'll multiply by like 3 over 3, which is still a 1, but it can actually make things look different. As you might guess, the most common wrong answer for this was 3/8. Just add the tops, add the bottoms. That works for multiplication actually, but not here. But again, that's the problem with the rule-oriented approach. I mean, there's a rule for this, but you haven't used it in a while. What's the rule? That's actually a pretty good guess. But again, if you think in terms of kind of sizes, clearly that's too small. That's less than a half. That's not even a half a pi. This by itself is actually bigger than that is. So it's not 3/8. As we saw, 13/15 is what we get. One reason I mention that is that some of you may not be used to doing a mathematical type questions in a multiple choice format. I know it may seem kind of sneaky when you first are told, but it's a pretty standard technique. I mean, they do it on the ACT and so on. If you have a question like this in a multiple choice format, usually if there's some obvious ways to get it wrong, those are going to be choices as well. So 13/15 is what it should have been, but as a multiple choice question, it's pretty likely that 3/8 would be on there as well. And if there's some other simple ways to get this wrong, I don't know, 2/15 or something, those be on there as well. So think of that when you do a multiple choice test. If one of the answers looks like it could have come from the numbers, don't jump right away without thinking about the other ones too. They may all look like they're possible, but think in terms of sizes and what the problem is really telling you and what makes sense.